Alright, g'day guys. Today we're talking about factorisation. So I'll just show you really quickly what factorisation is. So for instance, if we have A times B plus C, and we were to expand this, alright, it's going to be A times B, which would be AB, plus A times C, which is just plus AC. Okay, that's expansion. What we're doing in factorisation is we're going from something in expanded form back into factorised form. Okay, so we're going from expanded back into factorised. So we've got a number of examples here that we'll do together. We have 2x plus 2, and what we're doing is we're looking at both of these and we're saying, what's something they have in common? What's a factor, a number, or a letter that they might have in common? Okay, we can see both of them have 2. So if I pull 2 out the front, we're going to go 2 times what equals 2x, obviously x, okay, and 2 times what is going to give me positive 2, it's going to be plus 1, okay. We can then see if I was going to expand this, the answer would be 2x plus 2, so this is the answer in factorised form. 3x squared plus 5x, okay, 3 and 5 don't have a number in common, okay, but we can see they've both got x's in them. Here's x squared and here's x. So if we pull an x out the front, we're going to say x times what equals 3x squared. The answer is 3x. Okay, x times 3x would give you 3x squared, and x times what would give you 5x, just the plus 5 there. We'll fully factorise that one. They do get a bit more complex. Down here, rather than having an individual term in common, we've actually got a linear factor. Okay, we can see here's x plus 5 and here's x plus 5. So if I pull that out the front, all right, so I've got the x plus 5 bracket out the front with, what we're actually left with is just 3 plus x. Okay, now what we haven't done there is we haven't put 2x plus 5s into 1. We've factorised it out the front. Okay, so say for example, if this x plus 5 term, if we pretend that's a, we have x plus 5 over here, what we have is 3a plus ax. We can obviously see that a is common. We factorise the a out the front, and we have a times 3 plus x. Okay, so we can see it's the same answer, even though it might look a little bit more complex. Right, over here we have 2 times x plus 1 squared plus x plus 1. So I'm just going to write this out in expanded form first, so we can clearly see what the common factor is. And we have plus 1 times x plus 1. Alright, and so we can see here, here's one term, here's another term. Yeah, and obviously this is 1 times x plus 1. The factor they have in common is x plus 1. So if I pull x plus 1 out the front, what you can do is just obscure them. Okay, if we've pulled x plus 1 out the front, what we're left with is x plus 1 times 2 bracket x plus 1 plus 1. Okay, and then we can just simplify this using BMass. All right, this is x plus 1 times 2x plus 2. Okay, that 2 is going there and there. And then we have plus 1 on the end, close that bracket, and that just becomes x plus 1 times 2x plus 3. Okay, so it's just about looking for a factor that they have in common and pulling it out the front, just the opposite of expansion.